Okay, here is the official beginning of 4.4, systems in three variables. We're going to dive right into the first example, solve. And you notice, wow, this is a lot more intimidating than that practice problem, that prerequisite problem we just walked through. We've got three equations. Each of them have three variables. Part A, x plus y minus z equals 6, 3x minus 2y plus z equals negative 5, x plus 3y minus 2z equals 14. Also, it's common for you to see this big curly bracket around the left side there, and it sort of tells anybody, hey, this is one unit, like one system, all of this enclosed. But of course, it has the three parts. Okay, wow, where do we even begin to solve a system like this? So I'll tell you kind of the general strategy. We're going to try and find one variable. I pointed at x, but it doesn't have to be x. We're going to try and identify one variable. That's going to take a lot of work. Then, once we have one variable, it actually unravels pretty fast. We can find the second variable very quickly if we know what we're doing. And once we have two of the variables, we can find whatever the third variable is uh, immediately. And so we will, once we have that first variable, then it all comes together really quick. But it takes a lot of work to get that first variable. How are we going to do it? Here is our goal. Okay. We are somehow going to get two equations in two variables. We start with three equations and three variables, but we're going to manage to work with this using elimination to get it down to just two equations with two variables. Then we know how to solve that one. That's the prerequisite case. So the strategy is to boil this down to a simpler case and then solve that simpler case the way that we know how. That strategy is pretty common in math. As things get more complex, we try and break them down into more familiar things. Now, how we get the two equations in two variables varies from problem to problem. Some problems, you might take a certain angle to get two equations in two variables. Other problems, it's not so easy. We're going to look at different styles. We're going to look at two different styles, really. This one is the more general style. So what you see here, this is the first problem, so we have nothing to compare it to, but in every equation, we have an x, a y, and a z, right? In the first, second, and third, there's an x, a y, and a z. That doesn't always happen. Here it does. When every equation has an x, a y, and a z, then, well, there's no shortcuts, I guess is the way to put it. Here's what we're going to do. Here's our strategy. We're going to eliminate the same variable, but we're going to do it twice. We're going to eliminate the same variable with two different pairs of equations. Okay? So to eliminate, you need a pair of equations to add together. So we're going to do that twice, but we're going to make sure we eliminate the same variable each time. Okay, now if we were in class together, I would say, all right, you guys, let's look back up at the three equations and think about adding them and eliminating something. Which variable, x, y, or z, seems like the most natural or the easiest to eliminate? Keep in mind, you got to do it twice. And in my experience with this example problem, students say z. I mean, just look at the first and second equations. We don't have to do anything. We just add those two equations together and z disappears. Okay, it's actually not too hard to get something to combine with a third equation to get z to eliminate a second time. So I don't know if you were thinking that, but in the past, that's what a lot of classes have said. There's nothing special about z. You could eliminate x or y, but let's try and keep it simple. Let's eliminate z. I'm going to show you all of my thinking. We're going to eliminate z. Here's what we're going to do. Again, we need to do it twice. So the first way, number one, is to just add equations 1 and 2. Just add those together and z is gone. But we got to do it a second time. Really sorry for seems like the shadows are getting worse from the last video. Hopefully you can read this. Multiply equation 2 by 2, then add it with equation 3. So if we multiply that by 2, we'll have positive 2z, add it here, the z is eliminated. Of course, when we multiply, you multiply each term, all 4 of them in this case. Okay, it's really helpful to lay out this strategy, even write it down as you're getting used to solving these kind of systems. A big part of solving the systems is just keeping yourself organized, because it's so easy to make a small mistake somewhere along the line. Okay. Or forget you're in the middle of the problem, like, where am I in this problem anyway? I don't even know. Okay, let's go for it. Let's attack number 1, then number 2. And I know you can't see it on the screen anymore, but maybe you wrote it down, hopefully. There are, I'm going to cover this part up. That's just equations 1 and 2 as they are. We didn't change them. We're going to add them together. X plus y minus equals 6. 3x minus 2y plus z equals negative 5. Okay, when we add those together, we get 4x. We get negative 1y, so minus y. The z is eliminated, and 6 plus negative 5 is 1. Think of this as just 6 minus 5. Okay, hey, we got a new equation. It only has 2 variables. The z is gone. We're halfway to our first goal. All right, let's move on to number 2. I've got it down here. We are going to multiply equation 2 by 2. All right, I know it's not on the screen anymore, but it was 2 times 3x minus 2 times 2y, so minus 4y, plus 2 times z, so 2z, minus 2 times negative 5. Actually, that equation is right here. So that's equation 2. Everything got multiplied by 2 to get this equation. Then we're going to add it with equation 3. We don't need to change equation 3 because it's going to eliminate z again. So x plus 3y minus 2z equals 14. Okay, as we add each part, we got 7x minus y, negative 4 plus 3. The z is eliminated. Positive 4 over here. 7x minus y equals 4. All right, we obtained our first goal. We eliminated z twice. We got those 2 equations. This is a new system of 2 equations. And nothing new here. I'm just rewriting my final line for both those. So 4x minus y equals 1. 7x minus y equals 4. And you notice I put the curly brackets on there because I'm thinking of this like a new 2 equation system. All right. The hard work is behind us, but we're several steps from being done. We need to solve this system. We're going to get the values of x and y here. Okay. I continue this onto the next page. All right. How about that? 4x minus y equals 1. 7x minus y equals 4. So I'm going to go ahead and just use elimination again. If you're familiar with substitution and you want to go for substitution once you get it to 2 equations, I think that's fine. But personally, I think elimination is better anyway. So let's see, what can we do? You might notice, well, the y's are close. You know, I just need one of them to be positive. Well, that's no problem. I can multiply, say, the first equation by negative 1. And then I can eliminate the y. So here's what would happen if I multiply equation 1 by a negative. Negative 4x plus y equals negative 1. And I'm just going to take equation 2 the way it is. 7x minus y equals 4. Perfect. I can eliminate y's here. 3x equals 3. You might be thinking, why did I choose to eliminate x? Or I mixed that up. Why did I choose to eliminate y? I don't know. It was easier in my eyes to do that. Could we have eliminated x? Sure. I'm just doing the simplest thing that occurs to me. So 3x equals 3. Hey, I can just divide by 3 and x equals 1. Okay, this is great news. As soon as you get the value of one of the variables, now it's going to unfold pretty quick. So we're going to take that x